meter cubed indicates that it is probably half rock and half ice. Again, we have to spend time and resources on Charon if we want to figure out more details about it, but this is what we estimate at this time. Reese, how are you? I'm better, but I've been sick. Thank you so much for coming to the live. Although the surfaces of Pluto and Charon have been observed with the Hubble Space Telescope, that is, by the way, getting time on Hubble Space Telescope is, something that a lot of astronomers, want to do. If you want to get a PhD in astronomy, you might have to request time on the telescope, that is. The limits, so although the surfaces of Pluto and Charon have been observed with the Hubble, the limits on angular resolution mean that features smaller than a few hundred kilometers across cannot be seen. So even the Hubble will struggle to see things with a lot of resolution when they're so far away. Even at low resolution, however, it is apparent that Pluto has variations in its albedo. So now remember, what is albedo? The darkest, so albedo has something to do with reflectivity, okay? So the darkest regions, remember we talked about that with all the other, with all the planets as well, and some of the moons as well, and tells us something about the atmosphere, the surface, things like that. The darkest regions have albedo of less than 0.5, while the brightest regions have albedo of 0.66. This is surprisingly bright compared to other icy bodies in the outer solar system. Icy bodies darken over time because, among other causes, long exposure to solar UV radiation tends to darken methane ice. So now remember that when we say icy bodies in our solar system, we don't just mean ice as in water ice. It can be some other compounds ice form. So methane is one of them. So methane ice can be kind of darkened over time from exposure to solar UV radiation. One second, sorry, I had to mute that. Icy bodies darken over time because, among other causes, long exposure to solar UV radiation tends to darken methane ice. The explanation for the anomalous, so we expect that methane ice will darken, but there's this anomaly of the brightness of Pluto, which seems to be kind of higher. So the explanation for the anomalous brightness of Pluto lies in its eccentric orbit. Because the orbit is so eccentric, right? It's a very strange orbit compared to the planets, to the other planets. And I keep saying other planets because somewhere in our brain, Pluto is sort of the 9th planet. At this point, we know it's a dwarf planet, but there we go. The explanation for the anomalous brightness of Pluto lies in its eccentric orbit. The surface temperature of Pluto at perihelion, so peri, again, remember, means near. So perihelion meaning when it's closest to the sun. It has a temperature, the perihelion distance is 29.6 astronomical units, and the temperature there is 51 kelvins. So very cold. I mean, 51 kelvins is quite cold, for example, compared to us on Earth, but remember we're talking trans-Neptunian objects, which is very far from the sun. So that is considerably warmer. The perihelion temperature, that is considerably warmer. Even though 51 kelvins sounds quite cold, but it's considerably warmer than aphelion temperature of 40 kelvins. So at aphelion, it's 40 kelvins is the surface temperature on Pluto. At perihelion, when it's closer to the sun, it's 51 kelvins. Okay. Goodness. So once again, the surface temperatures of Pluto are 40 kelvins at perihelion, aphelion, ap meaning away, and 51 kelvins at perihelion, peri meaning closer. At perihelion, some of the atmosphere sublimes. So again, as you can imagine, as Pluto is going through its orbit, of course, it's sort of life is kind of different as it's at different distances from the sun, and it's a very eccentric orbit. So quite a bit of a difference between Pluto's perihelion versus